welcome to EGBTech channel. Myself, Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I will discuss about the Thevenin's theorem. How to solve the given problem by using Thevenin's theorem. First of all, what is the statement of the Thevenin's theorem? It can be states that in the given circuit, it consists of any number of voltage current sources and any number of resistances. Then that circuit can be replaced by a simple circuit, that is a single voltage source in series with a single resistance. A single voltage source in series with a single resistance. That circuit is called the Thevenin's equivalent circuit. In the given circuit, the first aim is to find out Thevenin's equivalent circuit. Then, how to find out Thevenin's voltage? You must find out the Thevenin's voltage across open circuit terminals, and to find the equivalent resistance across open circuit terminals. Then here the important point is, where is the point? That is the open circuit terminals. You must open the terminals where you have to find out the required response. That is current passing through resistance or voltage across resistance, like that. First of all, you can open the terminal. At the terminal, you can find out open circuit voltage, at the same time equivalent resistance. That voltage is called the Thevenin's voltage, and that resistance is called the Thevenin's resistance. In case of a circuit also, you have to find out the Thevenin's impedance in the form of RLC. That is the, you can find out the complex number, that is called the Thevenin's impedance. Then I can explain the Thevenin's theorem by taking the a simple circuit here. Consider this circuit here. This is the given circuit. In the given circuit, the load resistance RL value is not given. Then, but you have to find out the Thevenin's equivalent circuit across the terminals AB. That is across RL. Across RL, you have to find out the equivalent resistance. Then, what is the first step? That is step 1. In solving Thevenin's theorem, the step 1 is to find out Thevenin's voltage, that is denoted by VTH. That is first step, to find out Thevenin's voltage. Where you have to find out Thevenin's voltage, first of all, you can open the resistance, where you have to find out the response. Here, in the given problem, you are finding the response across RL resistance. That's why that RL is eliminated, like that here. That is, RL resistance will be open circuited. At that open circuit terminals, you have to find out the Thevenin's voltage. That's why here taken as plus, minus. At this open terminals, you have to find out Thevenin's voltage. Then consider here, apply KVL. We have two loops. After opening RL, the circuit changes into two loops. Then I am considering first loop current is I1 and second loop current is I2. Okay. In the circuit, already in the loop, second loop, we have a volt current source, that is 2 amperes. That's why I2 value is 2. I am taking direction also, same direction of the source. That's why taken positive value. I2 equal to 2 amperes. Then simply apply KVL to the first loop. That is mesh analysis. Apply KVL to only first loop. Then 4 plus, that is 4 plus 12 I1. Again, 12 ohms is the mutual element, and also I2 is also passing, but I1 and I2 both currents are same. That's why plus 12 into I2, then voltage source is 32. Here we know the I2 value is 2 amperes. Then we can replace the I2 value here, that is 16 I1 plus 24, 12 into 2, 24, that equal to 32. From the I1 equal to 32 minus 24 by 16. Okay? You can solve that value. I1 value you will get here 0.5 amperes. After finding current value I1 and I2, then you have to find out Thevenin's voltage here. Then you can understand here the very important point is here AB terminals are open, but VThevenin you have to find out across 2 ampere source. Why? Because there is no current passing through 1 ohm. That's why there is no voltage drop across 1 ohm. That's why you have to find out current passing through only 2 ampere source. And also that 2 ampere source is parallel with 12 ohms. That's why you can find out Thevenin's voltage across 12 ohms only. Then therefore Thevenin's voltage. Thevenin's voltage with H equal to 12 into what is the drop across 12? Both currents are passing in same direction. That's why taken as I1 plus I2. That is 12 into I1 0.5, I2 2, then 2.5. That's V Thevenin's voltage is, that is 30 volts. That is the first step. In the given circuit, first open the terminals. At that open terminals, you have to find out the Thevenin's voltage. Then, whatever second step, that is step 2, is nothing but to find out Thevenin's resistance, that is denoted by RTH. You have to find out the Thevenin resistance across open circuit terminals. Here, AB terminals are open. Across AB terminals, you have to find out RTH. Okay. Here, important point is anywhere you will find out the Thevenin resistance or equivalent resistance. All sources are eliminated. If the voltage source is there, it should be short circuited. In the given circuit, current source is there, it will be open circuited. Then this circuit can be formed like that here. That is 4 ohms and 12 ohms. Both are parallel. That is connected to 1 ohm. At this point, we have to find out RTH. You can draw circuit like that. Then, therefore, Thevenin's resistance RTH is 4 ohms in parallel with 12. That combination in series with 1 ohm. That is, two values are in parallel. What is the current value? R1, R2 by R1 plus R2. Then, by simplifying that equation, you will get RTH value is 4 ohms. 4 ohms. Okay, this is the second step. First step is to find out Thevenin's voltage, and second step is to find out the Thevenin's resistance. Then after that, the final step is to find out, to draw Thevenin's equivalent circuit, that is to draw the circuit is called Thevenin's equivalent circuit. Then what is equivalent circuit? A voltage source in series with resistance. That voltage source is the our finding VThevenin's, and series resistance is our finding RThevenin's. Okay. Then across this point is nothing but AB point. Okay, across AB point, the total given complete circuit reduced to a single source in series with a single resistance. Then again, you can replace the deleted element across AB. This is the called the Thevenin's equivalent circuit across RL. If RL value is given, for example, in the problem, then find out after drawing the equivalent circuit, then we can find out the current passing through RL or voltage across RL by simply applying KVL in single loop. Okay, in this way, you have to find out the Thevenin's voltage and as well as Thevenin's resistance. The Thevenin's voltage you can also apply for AC circuits also. That is, I am simply taken one AC circuit. Then here our aim is to find out the current passing through the branch 4 plus J6 impedance. Here two sources are given, that is 100 voltage source and 50 voltage source. Both are given in polar form. You can convert into rectangular form. 100 plus J0 and 50 0 plus J50 volts. These are the required polar forms, rectangular forms from the given polar forms. Then, what is the first step? Already we know. To find out Thevenin circuit, what is the first step? To find out Thevenin's voltage. How to find Thevenin's voltage? Wherever you can find out response in the given circuit, that element is, first of all, that element is to be eliminated. Then after that, across that deleted element, you can replace Thevenin's voltage here. Only you can find out the voltage across this node point and this node point, not complete voltage. For that, first of all, you can find out voltage drop across each element. That is the, you can find out the loop current. Then here a simple loop current is there. We have two voltage sources. Current is passing from lower potential to higher potential through 100 and higher potential to lower potential through 50. Then we are taken as I equal to, that is 100 positive minus J50 negative. That is total voltage by total impedance. That is what total impedance value here? 2 plus J5, one impedance value, and similarly 3 minus J5, one impedance value. Both are adding here. Then plus J5 minus J5 will be cancelled. Then 2 plus 3, 5. Then current value is 20 minus J10. That is the rectangular form, the current. That rectangular form you can convert into the polar form. That value is 22.36 at an angle minus 26.57 degrees. That is current passing through the branch. Then after that, after finding the current passing through the all elements, then you have to find out Thevenin's voltage by simply applying KVL across 100 and 2 plus J5 and VThevenin. Across only these three terminals, you have to find out KVL, then you will get 100 minus then 2 plus J5 into I. The voltage drop across 2 plus J5. Then we know the value of I here. Then you can replace the value of I 2 plus J5 into 20 minus J10. Both are multiplied and each other to simplify the equation. Then you will get the Thevenin's voltage is 10 minus J80 volts. That is the Thevenin's voltage. After finding Thevenin's voltage, this value also you can change into polar form. Then what is the next step? Step 2 value is to find out Thevenin's resistance. Here this is AC circuit. Then you can find out Thevenin's impedance. In order to find out equivalent value, all sources are eliminated. In the given circuit, two sources are voltage sources. That's why two sources are to be short circuited. If the current source is given, for example, then it will be open circuited. At open circuit terminals, you have to find out R Thevenins, not Z Thevenins. That is the impedance. Therefore, equivalent impedance, that is Thevenin's impedance nothing but here I have observed clearly here the two elements 2 plus J5 and 3 minus J5 both are connected between the same nodes. That's why two elements becomes parallel in connection. That is same Z1 Z2 by Z1 plus Z2. Then you can simplify the value. You will get 6.2 plus J1 ohm. That is the Thevenin's impedance value. After finding Thevenin's impedance value, what is the final step? That is, you must draw the Thevenin's equivalent circuit. How to draw Thevenin's equivalent circuit? That is a voltage source. This is AC source. Then that can be connected impedance. This voltage source is VThevenin. That value we will get 10 minus J80 volts and Z Thevenin, this is Z Thevenin, that value we will get 6.2 plus J1. Then after drawing equivalent circuit, then the deleted element is connected in series with the line. That is, what is the deleted element? That is 4 and J6. Then the Thevenin circuit is a simple loop circuit. Then what is our aim? To find out current passing through impedance 4 plus J6 impedance. That's why you can find out simply the loop current is I. Total voltage value is 10 minus J80 by total impedance 6 plus 2 plus 4 real values plus J 1 plus 6 imaginary values. Then you can simplify the equation. Then you will get minus 3 minus 5.79 amperes. Suppose you will change into polar form, that value is changed into polar form, then the final current is 6.52 minus 117.4 degrees. That is amperes. Okay. In this way, you can find out the Thevenin's resistance and voltage and draw the equivalent circuit, then find out the loop current. For given any circuit, the first step is you can open the element. At that open element, you have to find out VThevenin as well as RThevenin. Please subscribe our channel and share to your friends.